Hello, it is me, Mrs. Camp, and we are going to do another strategy for solving those tricky Math Olympiad problems. And today's approach is called the working backwards approach. This one is great because for me, it's pretty logical. So when you get a list of things that are happening in an order or a sequence, and they give you the final of something, you can work backwards to figure out what you started with. For example, we do this all the time with time in real life, right? I'm a mom. I tell my kids we have to leave at 5 o'clock. Your rooms need to be done. You have to brush your teeth, and you have to put the dishes away before then, right? And so my kids know how long it's going to take to finish the rooms, brush their teeth, and do the dishes. So they start with 5 o'clock. That's our goal, and they subtract the time they need for those tasks to know what time they need to start. I'm sure we've all done this before. But today, let's do it with math. Are you ready? So in order to do this video, you need something to write on and something to write with. And you need to be ready to pause the video because I'm going to have you do some work along the way. Here we go. All right, so our first one says, in a Fibonacci sequence, each number after the third number is the sum of the preceding numbers. And preceding means just the numbers that came before. For example, in the first three numbers, if they are 5, 6, and 7, then the fourth number is 18 because the sum of 5, 6, and 7 is 18. And then the fifth number is 31 because now we're taking the next set of three numbers in the sequence, so 6, 7, and 18, and adding them together to get 31. And we could continue this sequence on and on in the Fibonacci sequence. Okay? So here we go. The first five numbers of another Fibonacci sequence are P, Q, 86, 158, and 291, in that order. The question is, what's the value of P? So what we want to do here is the first thing I'm always going to do when I see a list or a sequence of tasks, I'm going to list them out so I can visualize them. And so there they are. Go ahead, write that on your paper. And now we know that the sum of the first three numbers is the fourth number and so on, so let's work backwards. So go ahead and write down 291 minus 158 minus 86. We're working backwards to find Q because we know that that is how we got to where we are in 291. We added Q, 86, and 158 to get 291, right? So let's go backwards. Go ahead, write that down and do the subtraction. Find the difference, plus press play when you're done. Ready? All right, so when you did all of that math, did you get 47? If not, see where you went wrong, okay? But the answer Q will be 47. So what we're going to do is now we're going to look at the next set of three digits, so which would be 86, Q, and P, and go from there, okay? So we know that 158 plus 86 plus Q equals 291, and so now we can work backwards to figure out what P is. So instead of Q in the sequence, we're going to put 47. Working backwards, we're going to do 158 minus 86 minus 47 to get us what we start with. Go ahead and do that math. Press play when you're done. All right, when you did all of that, did you get 25? Okay, that one is pretty straightforward, especially when it gives us the word sequence. We know that we're doing something in a certain order, and it gives us they're asking for the starting number, right? All right, let's go on to the next problem. All right, so this next problem is more of a scenario problem, so let's check it out. Paul has half as many pieces of candy as Jennifer. Jennifer has half as many as Charles. Charles has 12 times as many as Susan, and Susan has 4 pieces. How many pieces do Charles and Paul have all together? So the first thing I notice is that they're giving me a sequence or a list of things that are happening. And they end with telling me that Susan has 4 pieces, but they're not telling me what anyone else has or how it begins. So let's list that out. Right? It goes from Paul to Jennifer, Jennifer to Charles, and Charles to Susan. And they're telling us that Susan has 4. So we can use that information to work on backwards. Here we go. So write that down on your paper. They say that Charles has 12 times as many as Susan. So what we're going to do is take the information that we know, and we know that Susan has 4, and Charles has 12 times that. And so when we do that calculation, we should understand that Charles has 48. Let's keep going backwards. The next step says that Jennifer has half of what Charles has. And so we're going to take Charles's 48, and we know that Jennifer has half of that. And so that gives us the information that we need and tells us that Jennifer has 24, right? And when we break it up like this and we work backwards, it makes more sense, right? All right, let's keep going. We have one more stop to figure out what Paul has, and then we got to do something else. So if Jennifer has 24, Paul has half of Jennifer. So we take 24, and we know that Paul has half of Jennifer. So that gives Paul how much candy, everybody? 12. Easy peasy, right? But that's not the question. The question wasn't how much Paul have. The question, remember, with these Math Olympiads is how many pieces do Charles and Paul have all together. And so in order to do that, we need to add Charles's 48 to Paul's 12. Go ahead, pause the video if you can't do that in your head. 60. Pretty simple, right? Again, what we noticed is it went through a series of people, and we knew what the last person in the series had, and we moved backwards from there, okay? All right, let's move on. Okay, time to try it on your own. Again, when you read through this, can you see a series of what's happening, right? There's a couple key words here, like finally, that help you understand how we're going to end up with things or the final result, but we don't know the start, right? Go ahead, pause the video if you get stuck. Remember, list it out first. See if you can see how the sequence moves and how you can work backwards from there. Press play when you're done. All right, how did you guys do? Did you see that we have a series of events happening here? And for me, it says, what number did she start? Right there, I know. I don't know the start, but I know the finish. Let's go backwards. And so the first thing we do is we write out the series of events that she did. So she multiplied something by 3, then she took that something and added 4, and she took that something and divided it by 2 to get the finish of 14, okay? So you may or may not know that what you're asking yourself is you're saying, what divided by 2 equals 14, right? And so if that's what you did to find out that it was 28, that's great. But what you're really doing is what's called the inverse operation. And so you're multiplying 14 by 2 to find out that it's 28. And in math, we call that the inverse operation, okay? As you get older, you'll use this strategy a lot, but it's something that you probably did inherently knowing it before you knew what to call it, right? And so now we know that the last thing she did was took 28 and divided it by 2. And then how did she get that 28? She added 4 to something. So what is the inverse of adding 4? It's subtracting 4. So if we subtract 4 from 28, we end up with 24. So simple, right? As soon as you chart it out and go piece by piece, everything falls into place. And so the second thing she did was add 4 to 24. But she got 24 by multiplying something, the number she started with, by 3. So in order to figure that out, we do the inverse. We take 24 and divide it by 3 to find out that the first number she had was 8. How was it? Not too bad, right? All right. When can you do this? If you are looking at Math Olympiad problems, if you go on the website and you're like, should I work backwards? You're going to ask yourself, do they give us the final result of something? If they do, there's a good chance you want to use this approach, right? Are there multiple conditions given in a sequence of events, right? A series of events that you have to follow the order. Chances are that's a good way to use the reverse order, okay? Where can you find these problems? Today, all of the problems came from Volume 2. However, Volume 3, Volume 1, here's some great examples. There's problems in each of the books for you to use to practice this approach. And as always, the Math Olympiad website offers a lot of options for you to practice from as well that change often. Great job, everybody.